Welcome, my dear learners, to another interesting episode on civil tutorials. Remember, we are still on number basis. Number basis. In today's lesson, we shall be looking at equations involving number basis. Equations involving number basis. But before we start our lesson, we have to look at the lesson objective for today. So at the end of today's lesson, you, my students, should be able to solve simple equations involving number basis. If you are new on this video channel, kindly like, share, and most importantly, subscribe to this video channel for more updates. So let's start. Equations involving number basis. So here, a numeral with an unknown base is equated to a numeral with a known base. So let's take it that you have 102 base x is equal to. So realize that this is a numeral with an unknown base. We don't know the base of this numeral. It's been equated to a numeral with a known base. So let's say 51 base 6. So when you have questions of this nature, we are going to express each side of the equation as a base 10 numeral, and then we solve for the value of x. Similarly, when you have a numeral such as 2, 3, 3 base 4 is equal base x is equal to, let's say, 45 base 10. Now realize that we have a numeral with an unknown base, which is indicated as what? Base x, being equated to a numeral with a known base, which is what? Base 10. But realize that this has already been expressed in base 10. So we don't have to worry ourselves expressing this in base 10 again. All what we are going to do is that we are just going to express all this one as a base 10 numeral and then solve for the base x. That is what we are going to do. So let's take our first example and then see how it works. So we have our first example, which says that given that 25 to the base of x is equal to 17 to the base of 10, we have to find the value of the base x. So realize that we have a numeral with an unknown base. We don't know the base to which this numeral has been written, being equated to a numeral with a known base, a base of what? 10. We have to find the value of x, or the base x. So let's see how it goes. So we have our solution. So we have 25 to the base of x is equal to 17 to the base of 10. So as I said earlier on, when you have questions of this nature, we are going to express each of the numerals as a base 10 numeral and then we solve for the value of x. So we have this, we are first going to convert this to a base 10 numeral. Already, this has already been expressed as a base 10 numeral, so we are not going to touch this. But we are going to express this rather as a base 10 numeral. Is that clear? So we have 25 to the base of x. Now we have already learned how to convert other bases to a base 10 numeral. So we are going to apply the same method in converting this to a base 10 numeral. If you have forgotten, kindly go back and then watch the previous videos on that. So in doing that, we are going to write this number as it is. in order. So we have 2 and then 5. And then the next thing that we are going to do is that we are going to multiply each of these numbers by the base given. So the base is what? Base x. So we multiply each of these number by the base given, and then we sum them. Multiply by the base given, and then we sum them. So the next thing that we are going to do is that we are going to start counting from the extreme right to the left. Start counting from where? 0. So the counting starts from 0 on top of the number base. So we have 0 and then 1. Now what is left is simplification. So we are going to get 2 times x power 1 is still x plus 5 times x power 0 is 1. Any number raised to the power 0 is 1. So we are going to get 2 times x will give us 2x plus 5 times 1 will give us 5. So we have expressed this in base 10. So we have 25 base x is equal to 2x plus 5 base 10. Now this is in base 10, this is in base 10. So we can equate them and then solve for the value of x. Is that clear? Good. So let's equate them. We have 25 base x is equal to 17 base 10. Now this is equal to this. We are going to write this in place of that. So we are going to get 2x plus 5 is equal to 17. Good. Now we are looking for x. So at this point, what do? We do what we call transposition. So we are going to transpose 5 to this side of the equation. And we are going to be left with 2x is equal to 17 minus 5. So we have 2x is equal to 17 minus 5 will give us 12. We are looking for x. So what do? We either divide both sides of the equation or we multiply both sides of the equation by the multiplicative inverse of 2. And that is of 1 over 2. So multiply here by, multiply here by 1 over 2, multiply here by 1 over 2. This is called the multiplicative inverse of 2. Is that clear? So we have this, we divide this will also cancel this. So we are left with x is equal to 6. Good. So we have the value for the x to be what? 6. Now always after finding the value of the base x or the value of the base number, you can always cross check it. You can cross check it by converting this number to a base 10 number to see if you are actually going to get 17 base 10. So let's try that one. Let's cross check it. So we have check. So we have 25 to the base of x. X is what? 6. So we are going to convert this to a base 10 number to see if we are going to get 17 base 10. So we are going to write 2 and then 5. And we are going to multiply each of these numbers by the base given. So the base is what? 6. So multiply here by 6. We sum them. Multiply here by 6. We sum them. Then after that, we start counting from the extreme right to the left on top of the number base. So we have 0 and then 1. So this is going to give us 2 times 6 power 1 will give us 6 plus 5 times 6 power 0 will give us what? 1. So we are going to get 2 times 6 will give us 12 plus 5 times 1 will give us 5. And this is giving us what? 17 base 10. And this is the same as that. So our base x is actually equal to 6. Let's take the next example. It is your example. Pause the video, you try your hand on it. So this is your example. Pause the video to try and analyze it. Okay, so what did you get? I guess we're able to find the base n. Let's all of us solve it together. So we have 102 base n is equal to 51 base what? 10. So as I said earlier on, when the number is written without any base assigned to it, it is being assumed that that number is written in base 10. So this number is in base 10. Good. So what we are going to do is that we are going to convert 102 base n to a base 10 number and then solve for the value of the base n. Good. So let's convert 102 base n to a base 10 number. So we are going to write this number in order as it is here. So we have 1, 0, and then 2. And then we multiply each of these numbers by the base given. Good. So we have multiplied here by n. We sum them, multiply here by n. We sum them, multiply here by n. So what we are going to do is we are going to start counting from the extreme right to the left on top of the number base, starting from 0. Good. So we have 0, 1, and 2. So the rest is just simplification and manipulation of figures. So we have 1 times n power 2 give us still n power 2. And then we have 0 times n power 1 give us still n plus 2 times n power 0 give us what? 1. Any number raised to the power 0 is 1. Good. So we have 1 times n squared will give us n squared plus 0 times n will give us 0 plus 2 times 1 will give us 2. So we can see that 102 base n is equal to n squared plus 2. Good. So we have expressed this in base 10. So all of these are in base 10. So we can equate them and then solve for the value of x. So let's continue from here. So we have 102 base n is equal to 51 base 10. But this has been expressed in base 10. So we are going to replace this by that. So we have n squared plus 2 is equal to 51. So what do? You do what we call transposition. So we are going to transpose this to this very side, and then we'll be left with n squared is equal to 51 minus 2. So we have our n squared is equal to 51 minus 2 give us 49. We are looking for n, not n squared. So we take the square root on both sides of the equation and then we solve for n. So realize that the root of 49 is 7. Therefore, the value of the base n is 7. Very, very simple. We take our next example. It's still your example. You have to solve it. So this is the example. Pause the video. You try your hand on it. So let's solve it together. So we have 24 to the base of 5 plus 11 to the base of s is equal to 17 to the base of 10. So you realize that this is not in base 10. We don't know the base to which this has been written, but this is in base 10. So we are going to express this as a base 10 numeral, and then this also a base 10 numeral, and then equate it to 10. We solve for the value of x. So we have this 24 base 5 plus 11 base x is equal to 17 base 10. So let's first convert 24 to the base of 5 to a base 10 numeral first. So we have 24 base 5. We want to convert it to base 10. So we have 2 and then 4. Then we multiply each of these numbers by the base given. The base is 5. We sum them, multiply here by 5. We sum them. So the next thing that we are going to do is to start counting from the extreme right to the left, starting from where? 0. So we have 0 and then 1. So what we are going to do is just a matter of simplification. 5 raised to the power 1 will give us 5 plus 4 times 5 raised to the power 0 is 1. So we are going to get 2 times 5 is 10 plus 4 times 1 is 4. So this will give us 14 base 10. So we have 24 to the base of 5. So 24 to the base of 5 is equal to 14 to the base of 10. Now let's convert this to also a base 10 number. So we have 11 base x. So we have 1 and then 1. Then multiply each of these by the base given x. We sum them, multiply by x. We sum them. And then we start counting from the extreme right to the left. So we have 0 and then 1. So let's simplify. We are going to get 1 times x is still x plus 1. This one will give us 1. 1 times 1 is 1. So this is in base 10. So all of them are in base 10, base 10, base 10, base 10. We can equate and then solve for the value of x. So we are going to get 24 is 14 base 10 plus 11 base x is x plus 1, and then we have 17 to the base of 10. Now we are looking for x. So let's group the like terms, we add them, and then we transpose. So 14 plus 1 will give us 15 plus x is equal to 17. So let's transpose this to the other side of the equation. So, let's transpose 15 to this very side. So we are going to get x is equal to 17 minus 15. So we have our x to be what? 2. Very, very easy. I guess we were able to get 2 as the value for x. We take another example. It's still your example. You pause the video, you try your hands on it. So this is your example. Pause the video, you try your hands on it. So, are you done? What did you get? Let's solve it together, okay? So we have 124 to the base of n is equal to 232 to the base of 5. We have 124 to the base of n is equal to 232 to the base of 5. So you realize that this has not been expressed in base 10, or we don't know the base to which this numeral has been expressed. We are going to find out. This is in base 5 numeral. we are going to express this as a base 10 numeral. So this in a base 10 numeral, and then this also in a base 10 numeral. We are going to express all of this in a base 10 numeral, and then solve for the value of n. So let's start with 124 to the base of n. We have 124 to the base of n. Converting it to a base 10 numeral, we have 1, 2, and then 4. Then we multiply each of these numbers by the base given. So the base is what? N. So times n. We sum them times n. We sum them times n. Good. Then after that, we start counting from the extreme right to the left on top of the number bases, starting from where? 0. So we have 0, 1, and then 2. So the rest is simplification and the manipulation of figures. So we have 1, n power 2 is still n power 2, plus we have 2, n power 1 is still n power 1 or n, plus 4 times n power 0 gives us what? 1. Any number raised to the power 0 gives 1. So we have 1 times n squared will give us n squared, plus 2 times n will give us 2n, plus 4 times 1 will give us 4. So therefore we can say that 124 to the base of n is equal to the whole of this to the base of 10. Good. So we are done with this. Let's move on to this. We are going to convert this one to a base 10 numeral. So let's continue from here. We have 2, 3, 2 to the base of 5. So converting it to a base 10 numeral, we have 2, 3, and then 2. Then multiply each of these by the base given. So the base is 5 here. So multiply here by 5. We sum them. Multiply here by 5. We sum them. Multiply here by 5. So the next thing is start counting from the extreme right to the left, starting from where? 0 on top of the number base. So we have 1, 2, 0, 1, and then 2. So let's simplify. We have 2 times 5 power 2 gives us 25, plus 3, 5 power 1 will give us 5, plus 2 times 5 power 0 is 1. So we have 2 times 25 will give us 50, right? Plus 3 times 5 will give us 15, plus 3 times 1 will give us 2. So when we sum this, we are going to get 65, 67, right? 67. So you can therefore see that 2, 3, 2 base 5 is equal to 67 to the base of 10. Good. So we have converted each of these to a base 10 number. Let's equate them and then solve for the value of n. Is that clear? Good. So we have this to be this. So let's write this. So we have n squared plus 2n so we have n squared plus 2n plus 4 is equal to this one also give us 67. Good. Now let's bring the 67 to this side of the equation so that we can equate all of them to 0. Okay, so we are going to get n squared plus 2n plus 4 minus 67 is equal to 0. I guess you are following. So we have n squared plus 2n, 4 minus 67 will give us, I think, 63 or equal to 0. So you realize that at this very point, we have what we call a quadratic equation. And we have so many methods in solving a quadratic equation. You can use the computing of squares, you can use the factorization method, you can use the quadratic formula, also known as the almighty formula, and you can also use the calculator. Good. So let's use the factorization method. So we have 1, the coefficient of n squared is 1. We multiply by negative 63, we have still negative 63. And then we find two factors that when we find two factors of negative 63 that when we sum them, we are getting 2. And that is what? This times this will give us what? Negative 63. And this by this will give us positive 2. Are you following? Good. So let's substitute them in place of that. So we have n squared. So n squared minus 7n plus 9n minus 63 is equal to 0. So let's factorize n is here, let's factorize n out. So we have n is out, we are left with n minus what? 7. Let's bring 9 here, we are left with n minus what? 7 is equal to 0. Always the numbers within the bracket have to be the same. So this and that have to be the same, okay? Then after that, repeat those outside the bracket. So let's pick those outside the brackets, 9 and then 5, 9 and then n. So we have n plus 9, and then we pick any of the brackets. We have n minus 7 is equal to 0. Let's continue from here. So we have n plus 9, and then we have n minus 7 equal to 0. So we have n plus 9 is equal to 0, n minus 7 is equal to 0. So you can say that our n is equal to what? Minus 9. And then from here, our n is equal to positive 7. So n is equal to n is equal to negative 9 or n is equal to what? 7. Since the equation is true for only positive integers, we take our n to be what? 7. So we say that our n is equal to 7. Good. There is a value for the n. I guess you had this as your answer. Good. I'll give you another example. You try your hands on it. Where is the book? So find the value of x if 142 to the base of x is equal to 113 to the base of 4. Follow the same process and method and then find the value of x. Okay, this follows the same method as that. So try that one. Okay. So let's solve it together. So we have 142 to the base of x is equal to 113 to the base of 4. So realize that all of these are not in base 10. So we have to convert each of them to a base 10 number before we can solve for the base of x. So let's convert this to a base 10 number. So we have 142 base x. So we have 1, 4, and then 2. So we multiply each of these numbers by the base given. So the base is what? X. We sum them, multiply by x. We sum them, multiply by x. So what we are going to do is start counting from the extreme right to the left, starting from where? 0. Then 0, 1, and then 2. So the rest is simplification. So we have 1, x squared give us still x squared. Then we have 4 times x power 1 will still give us x. 2 times x power 0 give us 1. So we have 1 times x squared will give us x squared plus 4 times x will give us 4x plus 2 times 1 will give us 2. So that we can say that 1, 4, 2 base x is equal to x squared plus 4x plus 2 base 10. Good. Now let's convert 113 to base 4 to base 10. Sorry. We have 1, 1, 3 base 4 to a base 10 numeral. So we have 1, 1, and then 3. We multiply each of these numbers by the base given. So the base is what? 4. We sum them, multiply here by 4. We sum them, multiply here by 4. And then after that, we start counting from the extreme right to the left, starting from where? 0. So we have 0, 1, and then 2. So the rest is simplification. So we have 1 times 4 power 2 give us 16 plus 1. 4 power 1 will give us 4 plus 3 times 4 power 0 will give us 1. 1 times 16 will give us 16. 1 times 4 will give us 4. 3 times 1 will give us 3. So the whole of this is going to give us 23. Therefore, 113 base 4 is equal to 23 to the base of 10. So we have expressed each of these in a base 10 numeral. So we have this to that and then this to that. So we can equate them and then solve for the value of x. So we have x squared plus 4x plus 2 is equal to 23. I guess you are following. Good. So let's bring 23 to this side of the equation so that you can equate the whole of this to 0. So we are going to get x squared plus 4x plus 2 minus what? 23 is equal to 0. So we have x squared plus 4x. 2 minus 23 will give us minus 21 is equal to 0. So realize that this one, we also have a quadratic equation. You can use any of the method that I mentioned to find the value of x. Okay, so let's use the factorization method. So we multiply the coefficient of x squared by 21. We have negative 21. We find the factors of 21. That when we sum them, we are getting 4. And that is 7 and then 3. 7, 3, 21. 7 times negative 3 will give you negative 21. When you sum them, you are getting positive 4. Good. So we are going to get x squared plus 7x minus 3x minus 21 is equal to 0. So we factorize x out because x is here, x is here. So we have x is out. We are left with x plus x is out. We are left with 7. And then we have minus 3. We have x plus what? 7 or equal to 0. So always the numbers within the bracket have to be the same when factorizing and the quadratic equation. So we have x plus x minus 3. Let's continue from here. So we pick those outside the brackets. So we have x minus 3 and then we pick any of the brackets, one of them. x plus 7 all equal to 0. So you can say that x minus 3 is equal to 0 or x plus 7 is equal to 0. So from here, our x is equal to 3, or from here, our x is equal to minus 7. Good. So we have two values, but the equation is true for only positive integers. So we are going to take our x to be 3. So therefore, our x is equal to positive 3. Very, very interesting and then easy. I guess you have 3. You take a similar example and then we see. So try your hands on this, okay? Pause the video first and then try your hand. So we have our sixth example. We have to find the value of x if 4 times 13 to the base of n is equal to 54 to the base of n. So we realize that we have 54 to the base of n and then 13 to the base of n. But we have 4 here. This 4 is in base 10. So as I said earlier on, when the number or the numeral is written without any base assigned to it, we assume that that number is in base 10. So this is in base 10 and we don't know the base to which this has been written. So don't multiply, please don't multiply. First find or convert this to a base 10 number, and then after that you multiply what you get by the 4. That is how it is done. Is that clear? Good. So let's solve it together. So let's convert this to a base 10 number. So we have 4, then we have 13 to the base of what? N. So let's convert this to a base 10 number. So we have 1 and then what? 3. Then we multiply each of these numbers by the base given. So the base is what? N. We sum them plus n, we sum them. Then we start counting from the extreme right to the left, starting from 0 and then 1. So we have 1 times 1. 1 times n will give us n plus 3 times n raised to the power 0 is what? 3. Good. But remember, we have 4 here. So let's bring that one also to multiply by 4 to the base of 10. Now what we are going to do is to also convert this to a base 10 numeral. Let's continue from here. So we have 54 to the base of n. Converting it to a base 10 numeral, we have 5 times n raised to the power 1 plus 4 times n raised to the power 0. So we have 5 times n plus 4 times 1. 5 times n will give us 5n. 4 times 1 will give us 4, all to the base of 10. So all of them are in base 10. So we can equate them and then solve for the value of n. So we have 4 brackets n plus 3 is equal to 5n plus 4. So let's expand the bracket because all of them are in base 10, right? So we have 4 times n will give us 4n. 4 times 3 will give us 12. Then we have 5n plus what? 4. So let's group like terms, okay? So we can decide to bring the 4n to this side and then the 4 to this very side. Good. So we are going to get 5n minus 4n is equal to 12 minus what? 4. Good. So we have 5n minus 4n will give us n. 12 minus 4 will give us 8. So therefore our n is equal to 8. Very, very simple. Let's look at one that involves a word problem, okay? One example on that, and then we close for the day. So we have one example that involves a word problem, okay? So it says that, or it reads, a number is written as 25 to the base of x. Twice the number is written as 52 to the base of x. Find x. So let's see if we can fish out the mathematical statement from this word problem, okay? So we have our solution. So it says that a number is written as 25 to the base of x. So 25 to the base of what? X. Good. Twice the number is written as 52 to the base of x. So twice this number. So twice of this number is equal to 52 to the base of x. We have to find what? X. A number is written as 25 to the base of x. Twice this number is equal to, or is written as 52 to the base of x. We have to find what? X. To realize that this is similar to the earlier, you realize that this is similar to the earlier question that we solved. So we are first going to convert this to base 10, this to base 10, and then find for the value of x. So let's convert 25 to the base of x to a base 10 numeral. So we are going to get 2 and then 5. Multiply here by the base given, we sum them. Multiply here by the base given, we sum them. Then after that, we start counting from 0 and then 1. So we are going to get 2 times x will give us 2x plus 5 times x power 0 is still 5. But we have 2 here. So we have good. Let me write it one. So we have 2 multiplying 2x plus 5. Good. Then after that, we convert this one also to a base 10 numeral. So we have 52 to the base of x. So we are going to get 5 times x to the power of 1 plus 2 times x to the power of 0. 5 times x will give us 5x plus 2 times x power 0 will give us 2. So all of these have been converted to a base 10. We can equate them and then solve for x. So we are going to get 2x plus 5 is equal to 5x plus 2. All of them are in base 10. So we can expand the brackets. So we are going to get 2 times 2 give us 4 and then x. 2 times 5 will give us 10. Then we have 5x plus 2. So from here we can group like terms, okay? So let's continue from here. So let's group the like terms. We are going to get 5x minus 4x is equal to So this one will go here, 10 minus 2. So we are going to get 5x minus 4x will give us x, 10 minus 2 give us 8. So the value for x is equal to 8. Very, very simple. So this brings us to the end of today's lesson. I'm going to give you a tutorial set questions, write them down, and then you try your hands on it. Okay. So these are your tutorial set questions that are prepared for you. Kindly pause the video, write them down, and then you try your hands on it. This brings us to the end of today's lesson. Kindly like, share, and subscribe to this very channel for more updates. See you next week. Bye bye.